Today's video is going to be on Dalton's Law of Partial Pressure. So Dalton's Law of Partial Pressure tells us that the sum of two gases, so gas A, and I might use circles for gas A, plus another gas, gas B, whatever that might be, and I might have triangles here. So if I was to take gas A and gas B, and I was to place them into a container, so I have gas A and gas B, the total pressure of the container will be the sum of the pressure of A plus the pressure of B. And what I'd like to do is I'd actually like to rewrite this a little bit neater here because we want to put in a P for pressure. So the pressure of A plus the pressure of gas B will give us the total pressure. All right, that's A plus B. So if we were to look at a couple of practice problems. All right, if the partial pressure of oxygen and carbon dioxide are 565 millimeters of mercury and 225 millimeters of mercury respectively, what would the total pressure of the system be? So the total pressure of the system is going to be the pressure of the oxygen gas plus the pressure of the carbon dioxide gas. So if my oxygen gas is 565 millimeters of mercury and my carbon dioxide is 225 millimeters of mercury, then my total pressure would be 790 millimeters of mercury. So let's look at number 2. Acetylene gas was collected over water at 25 degrees Celsius. The total pressure of the gases collected was 715 torr. What is the partial pressure of the acetylene? And I've given you at 25 degrees Celsius the vapor pressure of water. All right, so this was collected over water. So what that means is we have two parts. We have the pressure of the acetylene gas, and we have the pressure of water vapor. So if the total pressure of the gases, that's my total right here, 715 torr, that will equal the pressure of my acetylene gas plus the pressure of the water, which we have found to be 23.8 torr. So when I solve for that, all right, I end up with the pressure of my acetylene gas to be 691.2 torr. So let's do a mixture. I have a mixture of 3 moles of argon, 4.5 moles of water, 1.75 moles of nitrogen, and 6 moles of carbon dioxide, and a total pressure of 900 torr. So I can find the partial pressure of each gas here, and the way I'm going to do that is by using my mole ratio. If I know the moles of argon for the total amount of moles, I can use that mole ratio to determine the partial pressure. All right, so I have 3 moles of argon. Now 3 plus 4.5 plus 1.75 plus 6 gives me a total value of moles of 15.25 moles. So here's my mole ratio, and my total pressure is 900. So I'm going to multiply my mole ratio by 900 torr, and that gives me 177 torr. We are going to do the same thing for water. All right, I have 4.5 moles of water. And again, my total is 15.25 moles. And we multiply that by our 900, and that gives us 266 torr. We can then do the same thing for nitrogen. Nitrogen has 1.75 moles. And my total is 15.25, which gives me 103 torr. Oh, I had to multiply that by 900. And my carbon dioxide has 6 moles divided by the 15.25 times 900, and that gives me a value of 354 torr. So what does this mean? Out of the 900 torr of total pressure, 177 torr comes from argon, 266 comes from water, 103 comes from nitrogen, and 354 come from carbon dioxide. Now you can check your work. Add these together. They should equal something very, very close to 900. Now remember, when we're doing these math problems, there may be some rounding involved in your final answer. So if that's the case, it may not be exactly 900, but it would be something really close, like 899 torr, something super, super close. All right, let's look at number 4. If I have 15 liters of gas collected by water displacement, I have a temperature of 25 degrees Celsius. Here's my pressure that is provided for me. All right, and then again at 25 degrees Celsius, I've been given the vapor pressure of the water. We want to know the volume of the dry gas at STP. So the dry gas, well, which gas is that? We have a sample of gas, and then we have water. Which one of those is the dry gas? When you go outside and it's raining, you get wet. Yes, the water hits your head and your head gets wet. Okay, so the dry gas is going to be this other gas. Step 1. We are going to have to do a PVTN problem. Now, we have 15 liters, and this is our IFE chart. Now, in this video, I'm making the assumption you know how to do these charts. If not, you need to go back and watch the video on PVTN charts as well. All right. What is my overall pressure? I have a total pressure of 11.2, and the water pressure is 3.17. So step 1, I have to subtract these values out. There is my pressure of the problem, 8.03. Now, I'm determining the volume at STP. I had to subtract these out because I want the volume of the dry gas. So I had to take my total pressure, subtract out the water to get the pressure of the dry gas. Now, standard temperature and pressure. Standard pressure of kilopascals is 101.325. And let me move my volume over a bit. Okay. Now, my temperature is going to be at 25 degrees Celsius, which is 298 Kelvin. And if I'm at standard temperature is 273, and my moles of gas here are not going to be a player. So I have 15 liters of gas. My pressure here went up. An increase in pressure decreases my volume. So I'm going to put the 8.03 on top and the 101.325 on bottom. Now my temperature here went down. A decrease in temperature decreases the volume. So I'm going to put my ratio of 273 on top and the 298 on the bottom. So when I plug this into my calculator, I find my new volume to be 1.01 liters. All right, our final type of problem for Dalton's Law. The partial pressure of chlorine is 400 torr in a mixture of gases where the total pressure is 1520, and we want the percentage of chlorine in the mixture. So all I'm going to have to do here is look at the ratio of my pressures. All right, chlorine is 400 torr, and my total pressure is 1520 torr. Now here's my ratio, and to convert that into a percentage, I will simply multiply by 100 to give me 26.32%.